Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Mickey.
And in studio with us we have Jaxson. And if somebody needed to contact us, Jaxson, what would they need to do?
For math homework, help call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. Do you have all of that social media stuff?
No.
I don't have it either. I know we do for the show, but I don't have all that stuff.
Right.
Do you think you will when you get a little older?
I think once I turn an adult, yes, but I don't think.
That's a long way away, right?
Yeah.
Yeah, nothing to
anyway.
worry about right now.
Yeah.
So where do you go to school and what grade are you in?
I go to school at Bill Williams Elementary, and I am in the 5th grade.
All right, so obviously 5th grade just started, a couple weeks old now, right?
Yes.
So what's the best thing about 5th grade?
I think that, I honestly don't know, it's kind of the same of all the other grades, except that you just get older and you get to learn new stuff.
There you go.
And
Well, you know
plus-
what? Getting older and learning new stuff is important, and it's fun doing that, right?
Yeah.
Because you probably think, and the way you look at things is different than when you were like in 2nd and 3rd grade, right?
Yes.
Well, that's what you want to do, right? And the way your brain develops is by struggling and learning new things, and that's how you develop and grow your brain. So that's a great answer right there, right? It's just like I'm getting older and learning new things. Well, that's what we want all the time, right?
Yeah.
All right. What kind of stuff are you doing in math right now in your classroom? Do you know?
Currently right now we are doing multiplying double digits by double digits, and before that we are doing scientific notation with powers.
All right. So are you comfortable doing multiplication like that with the double by double?
Yes.
Have you done double by double with decimals in them?
Not decimals.
Oh, well, maybe we'll throw that in there today, and you and Mickey can work on that a little bit, all right? But before we do any of that, let's first take a look at today's Math in the News. All right, so Jaxson, do you ever read the comic strips or the funny papers or anything like that?
Not much.
Not much? Mick, what about you?
I tend to be the funner read of the newspapers some days. It might be a little more intriguing than a lot of other stuff that might be in the paper that day.
It is. So this is one that I found a couple of days ago. So let's take a look at it. I didn't even worry about the whole comic. We just need the part for us for Do the Math. So the one girl is saying, "Hi, Kaya. I'm Luann, and I'll be helping you with your home," and we know she's saying homework, right?
Yes.
Here's my problem. Is there a solution to an array of n times n if n equals 4k plus 2, where k is a positive integer? And then you can see the one girl look at her with some bigger eyes like, well, I'm not really sure what you're talking about, right? So do you get the humor behind that a little bit? Like the girl's like, I don't know what you're talking about.
Yeah.
You know, it kind of sounds a little bit confusing, right?
Yeah.
So in your mind right now, let's think about this. Let's take a look at the comic again. Is there a solution to an array of n times n if n equals 4k plus 2, where k is a positive integer? So could we take that apart and maybe look at it a little closer, do you think?
I honestly don't know.
Right, I
I
mean, it's
never
kind of
heard of it.
confusing, right? And you're in 5th grade, right?
Yeah.
These kids are in high school doing this, right? So let's take a look at it again quickly. So it says n times n. Do we know what n is?
It is algebra.
Right, it's
With-
algebra, right? And in the comic it says n equals 4k plus 2. Does that make sense?
Yeah.
So they say
4,000.
n times n, right? So if I said n is 2, 2 times 2. Does that make sense?
Yeah.
Right, if I say n times n is the same as 2 times 2, then we know n times n is 4, right?
Yeah.
So that's kind of what the comic is getting at. It may look a little complicated, but once you understand what they're looking for and substitute the pieces, it's a little bit easier to understand. So here's a little something that I found also, and I'll zoom out a little bit on this. And have you ever seen any of these symbols?
I've seen 2 of them. I've
Two
seen
of
the
them?
first and the second one.
Yes,
so you
my,
saw
my
the
inner
first
math
and
teacher
second?
is now giggling. It took me a second, maybe not. All right. Look.
So you know what that is, or you've seen it?
I don't know what it is, but I've seen it on Star Math.
Okay, so you've seen it, and you've seen this.
Yes.
Do you know what this is, or what it means,
Yes.
or what can you tell me about it?
It's 2 to the power of 3, which it'd be 2 with 3 zeros to it.
Close. So 2 to the power of 3 is 2 multiplied 3 times. So 2 times 2 times 2. If it had times 10 to the 3rd power, then we would say 2 with 3 zeros. Does that make sense?
yes.
Yeah, okay.
So you get your scientific notation in there and stuff
Yeah.
like that.
So 2
Have-
to the 3rd power would be 2 times 2 times 2, which would become what, Jackson?
2 times 2 times 2 times 4, 4, 8.
Perfect. So now we know that that 2 to the 3rd power really means 8. So let's keep going with that on the
So
on the
this
riddle
is
there.
8,
Okay.
and I'm sure you've never seen this symbol before.
Yeah, I haven't.
Okay. Have you ever seen this?
No.
Okay. Have you ever heard of pi in math?
Pi, no.
Okay. Well, hopefully in 5th grade you'll hear about Pi Day this year. All right. Pi Day happens on March 14th because it has to do with circles. All right. And on 3/14 we celebrate Pi Day. So this is the symbol for pi. So we're going to say this. All right. This is the symbol for sum. If you wanted a sum of numbers, you're going to add the numbers, and then you get the sum of the numbers to get a total.
Yeah.
Does that make sense?
Yes.
Okay. So this is the symbol for sum. This is the symbol for an imaginary number, which is written like that, I, for imaginary number. All right? So instead of looking at this way, when we look at it the other way with what those represent, what does it now say on there?
It says, I ate some pie 3.
Don't
And
worry
it
about the
was
numbers,
delicious,
just
right?
the
Wait.
word pi. Yeah, keep going.
Oh. And it was delicious.
So say it again quickly.
Pie, and it was delicious.
Right. So say the whole thing again.
Starting with I.
Skip
the whole
that.
thing
So
now.
start that and the whole thing.
Okay. I ate some pie, and it was delicious.
Does that make sense to you?
Yeah.
Yeah. See, now you get it, right?
Yeah.
So if you were to get some pie, what kind of pie would you like to have?
Cherry pie.
Cherry pie? Ooh, I dig the cherry pie too. If I was going to have a fruit pie, I would have a cherry pie first.
I'll take a pizza pie.
See, that's what I was going to
still
say.
a pie.
I'll have a
Little-
pizza pie,
little
right?
Different ingredients, but still a pie.
Right, because in New York we have pie, that's pizza, right?
Yeah.
But we'll take that other pie also, all right? So that is today's Math in the News. Figured we'd take a little comic, and sometimes parents want to help their students, but they don't quite understand what everything in mathematics is, or they don't remember when they did it a long time ago, and they want to help their
Absolutely.
student, which is exactly what we're here for. So if you need some help, we are here every Tuesday and Wednesday between 3:30 and 5:30 for your phone calls. Live show is moved from 4 o'clock to 4:30, so we're live on air from 4:30 to 5:30. If you do need to give us a call on any Tuesday or Wednesday, the phone numbers are at the screen periodically throughout the program. And we do have a phone caller right now.
Okay.
So let's go to the phones and, all right, I think that they're just about ready. All right, and is it Angela? Or is it somebody different?
It's different.
Okay. What is the problem you're working on?
Mm, Negative 87 minus
So I think negative 87, right? Okay.
yeah.
Keep going.
Negative 87 minus in parentheses negative 8.
So put parentheses, Mickey,
Okay.
and then put another negative 87 in there. Close parentheses, and I believe that's correct. Is that correct, Naomi?
Yes.
All right.
All right, Naomi. So in class, what does your teacher tell you about negative numbers or negative values?
Don't really tell me much about it.
Okay. So let's try to put it in a real world perspective. Let's say I want to go buy a new toy that's out or a new game or a video game example. And it costs me $87. But you know what? I don't have the $87, so I need to borrow $87. So if I borrow $87, do I have $87 or do I now owe someone $87?
You owe someone?
Exactly. So we represent that with a negative, okay? In this case, we're going to represent it as I owe someone $87. Does that make sense so far?
Yeah.
Okay. Now we know with subtraction it means, am I adding something or am I taking something away?
Taking something away.
Exactly. So we have currently, we owe someone $87, but we are going to take away the $87 that we owe. Are you following that? Does that make sense so far?
Yes.
Right? So because I owe someone $87, it's like, oh man, I owe you $87. But I'm going to take away the debt that I owe them. So if I owed them $87, but I take away the debt, or here's another trick that we can use, negatives mean opposite. Because negative 87 is the opposite of positive 87. Does that make sense so far that you're seeing it?
Yeah.
Okay. So what that means is, if I'm taking away what I owe, I have to add or give back that $87. So if I owed 87 and I'm now giving back the 87, do I owe them any money?
No.
No. But do I have any money left over?
No.
No. So what would I show with a number that would show I don't owe them money, but I don't have any extra?
0.
Exactly. 0. If I have negative 87 and I subtract negative 87, it's like being way over here at negative 87 on a number line. But I want to take this away. Oh, so I need to go back towards the positive. And I end up, just like you said, at 0. So 0 will be our sum, or in this case, our difference, because it's a subtraction problem.
Nicely done. So that helps you out, Naomi?
Yes.
All right. Well, thanks for that
Awesome.
phone call. If you do need some more help, we do have phone tutors available until 5:30 this afternoon. And this is our 21st season of Do the Math. So we certainly do enjoy being part of helping kids for that long. Did you have any idea that Do the Math was 21 years old?
No.
That's probably twice as old as you, isn't it? How old are you?
10.
10 years old. It's twice
Yeah.
as old as you.
Yep.
It's almost as old as Mickey, too. Right?
Yeah, fair enough. But you've been doing
Anyway.
it for 21 years, or going into 21 years. So,
Right, we're going into 21 years, and
so you've been here a while.
yeah, I've been here for a while. I've been here 21 years, going into 21 years. Anyway, 636-4357 is the phone number. And every single week, we have an opportunity to show you some places that Do the Math has had an opportunity to visit. One of the great places we had an opportunity to visit was Tejon Conservancy.
we have a little math in the real world to do. Everyone's favorite segment of the show. And we are back at Tejon Ranch. And my friend Mitchell, thank you so much for having us again. You know, last season we got a chance to be in kind of the valley portion, and we're in a different part of the ranch now. So tell us a little bit about where we are and what we're gonna do today, because doggone, we are next to a doggone big tree. It's crazy.
Sure. So relative to where we were last time in the San Joaquin side of the ranch,
Right.
we're on the Mojave side of the ranch now. So we're pretty far south of where we met last time, but we're
Right.
still on the ranch.
Still on the same piece of property.
Yeah, if you take a peek around at some of the habitat here, it looks pretty different from where we were last one. Was it November?
Right, very different. Yeah, no
Yeah.
doubt. Lots
And,
of flowers and different plants and obviously different animals as well.
Totally different plants and animals and soils, and it's very windy over here relative, so it's very different.
Yeah, very different. So we're standing next to this ridiculously large tree. And last time we talked real briefly about, you know, being able to calculate how many species of a certain plant on a certain area, right? So that's one kind of mathematical thing that maybe you do in your job.
Yes.
But another thing you do is try to determine the age of a tree, right?
Sure.
So tell us a little bit about that, because I'm so curious how you would look at this tree. I would say it's hundreds of years old and it's so gigantic it had to be really big, but that's not always the case.
Yeah, well, we often look at plants or trees or even animals in nature, and we try to guess how old things are, right?
Yeah.
And it's a very common thing that land managers, biologists, people who study trees specifically, they look at stuff like this and they actually measure it directly. And this tree in particular, the reason why I wanted to take you here is that we do tours on the ranch quite frequently over here. We have these abundant wildflowers.
Yeah.
And we drive up and down this canyon, and people look at this tree specifically. This is a California sycamore.
Okay.
And they say, wow, that's the biggest sycamore we've ever seen. How old is it? And so people say, oh, I think this tree is 200 years old. I think it's 80. I think it's 1,000 years old. And you get wildly different estimates.
Yeah.
You can't always tell. Some trees grow very quickly. Some trees grow very slowly. Actually, the oldest tree that's ever been cored on the ranch is one of the smaller trees out here.
Yeah.
It just grows very slowly, but it's the oldest.
Right. And so you talked about, you just said something about coring. What does that mean, and how do we determine? I'm sure lots of people know a little bit about the rings of a tree, right?
Yes, I have an example right here.
Yeah, so we can count the rings of a tree, and that's each year the tree trunk gets bigger and it adds another ring of what we would look at, right?
Exactly. So when a seedling germinates, every year that as it gets older, with every spring and summer season, it puts on another growth ring.
Okay.
And so if you take this is a cross section of a tree, and you're looking at it laterally like this, if you do something as simple as count the rings, you're literally counting how old the tree is.
And you can't always take a chunk of the tree out like this, because this is a really big piece of wood, and that would do
Yes.
some damage to the tree.
Exactly.
So, let's do some coring. I want to see this coring tool that you have,
So-
and how it works, and what happens when you do that.
So this is a tool, it's a non-damaging tool. It's sort
Okay.
of like taking a blood sample.
Okay.
It's called a tree core.
Yeah.
So what we can do is we can drill into this tree. It doesn't hurt the tree. This field, by the way, is called Dendrochronology. It's the study of annual growth rings.
Right.
And there are many, many different applications
Sure.
for this. So
Let's do it. Let me see you get this thing done
So
here.
this is how it works. It's got a drill bit right here. It's a very sharp end, kind of like a knife. And this might actually take a couple goes because everything's a little bit different, but you essentially drill in just like this, right? You want to make sure it's nice and level. And of course, the outermost ring, we're going to assume is 2022. And now that it's bitten in, we're just going to go ahead and start drilling in as far as we reasonably can. Beyond just determining the age, again, you can use this to quantitatively determine the health of the tree throughout its entire lifespan.
Right.
So we could go on a bit further, but
Right.
just to kind of compare them, this is a tool that you can use to extract the core. We'll just put it in there and take this core sample out.
Whoa.
Okay, so that's not a complete core,
Right.
but you can get a picture of what it looks like. And
Yeah.
so this obviously is coming from the outside. And so we're going to assume that whatever growth is on there from this year is 2022.
Right.
And you can't quite see the growth rings on this because it hasn't been processed yet, but you can imagine the annual growth rings going in this direction, the older the tree gets.
Right.
Okay,
Absolutely.
so we can't know. It takes some processing back at a lab to know.
Right.
So like you said, we got a fully processed core sample here just to show what it looks like on the other end. So we can just imagine this is actually a different species. It's a blue oak, the oldest blue oak that's ever been cored in California, to my knowledge.
Wow.
So we can just pretend here, this is obviously the dates are a bit different, but when you process it in the lab and you sand it down, you can see the growth rings really nicely like that. And so with this particular oak tree right here on this processed sample, it was cored in 2014, and looking back at the growth rings, it germinated, or at least this core went back to 1654. Wow. So this is the oldest oak tree that's ever been sampled in California.
Oh,
and you
man.
can do all kinds of analyses with this.
We want to know more. Gosh, there's so many amazing things to do, but we know there's also some more math to do back in the studio, so we'll be back in a bit with some more information from the Tejon Ranch.
All right, thanks for that, Scott. Beautiful place up in Tejon. A lot to learn, a lot to do if you ever have an opportunity up there as well. 636-4357 is the phone number. Phone tutors are available most Tuesdays and Wednesdays throughout the regular school year. In studio with us, we have Mickey today, and we also have Jaxson, a 5th grade student from Bill L. Williams Elementary School. And you are going to show Mick how you solve a magic square, correct?
Yes.
All right, head on over to the board and explain away.
Okay. So we have numbers,
Okay.
and we could start off with numbers, and we have a certain sum that we need to get to with using certain numbers only once in each square.
Okay, so using the numbers 1 through 9, or are different numbers?
It could be really any number as long as you can sum them up to the sum that you need to get to.
Okay, sweet. We have an example that we're working on.
Whatever one he wants to do.
Okay, or you're going to challenge me. Is that
Well,
okay?
he's done one, I think, already, right?
Yes.
So do you remember the numbers that you used?
I'm not 100% sure, but I believe, yeah, I don't know for sure.
Oh, all right. Well, how about if you guys try 1 through 9 and see if you can make that work?
Yeah, it's fine.
All right, let's do
Go
it.
ahead and try it.
So, do you give me numbers on the sides that I have to get to, or how does that work?
So you start off with a number that's inside a square,
Okay.
and you have other numbers, and you have to place them in the correct order. So you get the sum across that way, and that way,
Okay.
and up and down. So up, down, and diagonal.
And what's the number I want to get? Or they're already pre-put in there and I put the rest in to make it kind of like a Sudoku puzzle almost?
Yes.
I have to put the numbers where they fit?
Yeah.
Oh, very cool. Okay. Mike, is there any way you could give us an example of one that we could throw up here and work through, or do we want to get that later on the show possibly?
Let's do the numbers 1 through 9, and we want everything to add up to 15.
Okay. All right. So horizontally, vertically, right? I need to find ways to
And
put 1 through 9 in
diagonally.
Yes.
here. And diagonally. Okay, we're on a mission today.
And you're going to use the numbers 1 through 9.
Copy that. All right. Well, what do you think? How should we start?
I think we should. First, we kind of just have to place any number down. So let's start
Okay.
with the 8 in the middle.
Okay, 8 in the middle. All right, 8 in the middle. We'll need 7 more diagonally, so
We could do 3 and 4.
3 and 4. I'm liking it. I'm loving it. Okay. Bam. All right, so now we have 3 in this one, so I have to get 12 somehow, correct?
Yes.
All right. 7 and 5.
and yeah.
Oh man, look at that. We're on it. 7 and 5. Okay.
Oh, we could that won't work because
Yeah, because 7 and 4 is
Yeah.
11, and now we're missing this one. Okay.
Yeah.
All right. What is...
Well, maybe just reverse the 3 and 7.
Oh, there we go. Okay, we could try that. So we can reverse these. Mike's always on it, helping us out.
then we'd also need to change the 4 because those are already 15.
So we can put a oh, that wouldn't work then because we can't use 0,
Yeah.
can we?
No.
Oh man. Oof. All right, let's see here. So maybe
We can maybe add a 6 right there.
6 and then a 4 over here.
Yes.
Okay.
D-
4, 8. I'll make this
1,
a 3,
3, 1,
1, and then a 9 here. But then that gives us
Yeah,
17. That's too much.
You want a
Could we
suggestion?
maybe switch
Let's
spots
hear
right
the suggestion. Here we go. Hit me.
Put 5 in the middle.
5 in the middle, he says. Okay. All right. And work off of this?
Work off of that.
Okay.
Well, I mean, get rid of your other numbers.
Oh, okay. Now we're
Well,
getting
you know
really
what? Leave
specific.
your 9. I like the 9 there.
Oh, he's okay with the 9. All right, we can roll with that.
Get rid of the 4 and 6. Once you have the 9 and 5, that's going to help you with that middle row, and then go from there.
All right, Jackson, talk to me. What do you think we should do next?
So we should start off with 9 plus 5, which would be 14. So we should add a 1 there.
Okay.
For diagonally, we need to get to 10. So that would be
We can put a
15.
3
no.
here.
Yeah, 3.
No, because then we need a 3 up top.
So if it's a 6 right there, that would be too much.
That would still be, yeah.
So here's my
So then
thing to help you out.
4?
You've got a 1 on the far right.
Okay.
So you know you need 14. So what 2 numbers can you use to get 14?
8 and 6.
Yeah, and 8, 6.
8 and 5 is 13.
Yes,
Plus
2.
2 is 15. 2 and 9 is 11. So,
4.
okay. And
And
then
then 4 plus 8 is 12. 3
3. 3 and 5 is 8 plus
plus 8, 7.
1, 2, 3, 4, 5, 6, 7, 8, 9. Boom! There it is.
Well, hold on now. Let's try them all going diagonally,
Oh,
horizontally, and
okay.
vertically,
All
and
right,
make
all
sure
right.
of this.
All right, 4 and 9 is 13, plus 2
Yes.
is 15. 3 and 5 is 8, plus 7 is 15. Jackson, take it from there.
8 plus 1 is 9, plus 6 would be 15,
Cool, let's go this way. 4 and 3,
is 7,
plus the 8.
15,
Good to go. 9 and 5,
14,
plus 1 is?
15.
My man, keep it going.
2 and 7 is 9, plus 6 would be 15.
Last 2, here we go. 4 and 5,
9,
plus 6.
15,
Looks like we're almost winning. Here we go, last one. 8 and 5,
13,
plus 2.
15.
Yes.
All
Give me
right,
5.
so you guys were able to
Booyah.
accomplish the magic square, doing 1 through 9. Just that simple hint of putting 5 in the middle, and then you guys were able to go from there.
Good to go.
Nicely done.
Nice
Well, you know what? For your great effort right there, you've got yourself a meal courtesy of our friends at Broken Yoke Cafe.
All right.
And congratulations on that. I just love seeing those little chicks and those eggs right there. Have you ever been to Broken Yoke?
No.
Ooh, let me tell you something, son. You're in for a big treat over there. We usually go for breakfast. That's mighty fine breakfast over there, so make sure you're hungry when you go over there, all right? All right. 636-4357 is the phone number. We do have phone tutors available until 5:30. And don't forget, you can also email us questions at dothemath@kern.org. Remember, if you do email a question, it is best if you do it on Monday, Tuesday. That way we can look at it and hopefully answer it for you on Tuesday or Wednesday on the program. So Monday, Tuesday, or Wednesday would be the best days to probably email. That way we can address it directly on the program. You ready for another phone call?
Let's do it.
All right. Ollie, how are you this afternoon?
Good, how are you?
I'm excellent myself, thank you. What school do you attend?
I go to Cesar Chavez Elementary.
And what grade are you in?
I'm in 6th grade.
All right,
Yeah,
let's
best
hear the
grade,
math problem
all right.
that you're working on.
The problem that I'm working on says, according to the key of a particular park map, every 5 inches on the map represents 3 miles of trails in the park. How many inches on the map represents 9 miles on the park trails?
All right. So, Ollie, have you guys worked with ratios in class at all? The comparison of one quantity equals or represents another quantity?
Yeah, we have, and I'm having a little trouble understanding.
Okay, no worries. So the nice thing is with ratios, it's almost like using an equal sign. Instead of an equal sign, though, I have 3 options to make a ratio. I can use the word 2, I can use a colon, or I can represent it using a fraction bar. For example, 5 inches to 3 miles. Does this make sense to you?
Yes.
Okay. So using this, our goal is to figure out how many inches would it take to represent how many miles again? Was it 9?
Yes.
All right. So we currently know on the map 3 miles is represented by 5 inches. Yes?
Yes.
What strategy do you think we could use if we're going from 3 miles now increasing to 9 miles? What kind of change
Well-
are you seeing?
Multiplication.
Multiplication. Now be specific. Multiplying by what? A factor of what?
3.
Of 3.
Times 3.
We now need to see how many inches would it take to represent 3 times as much distance? Well, Ollie, if I'm doing 3 miles and now I'm looking at something 3 times as long, should the map correspond with 3 times as many inches?
Yes.
You are correct, absolutely.
So
And if
then
I do
it would
that,
be 15?
15 inches, yes.
Okay.
Now, a way to check this really quickly, because if you're ever doing this and you think, I don't know if this is right, the great thing about ratios is they can boil down, or you heard of simplifying with fractions before?
Yes.
Yes, that skill is going to make you confident in your answers, because what we can do is, if I can get this other ratio simplified down to the other one, or they can both be simplified to the same final fraction or ratio, they're equivalent. So what can I divide 15 and 9 both by?
3.
3. When I do that, it becomes 5 inches to, 3, not 9 again, 3 miles. Do these match?
Yes.
Yeah. So I know that this is a correct equivalent ratio, that I did my math correctly, and 15 inches is what I should see on that map.
So Ollie, I've got another way for you to check this also. So make cross multiply. So if you look at it cross multiplying, what's 5 times 9?
5 times 9 is 45.
Okay, and what's 15 times 3?
15 times 3 is 45, I think.
It is 45, right? So that's another way that you can look at the answer and check to see if that is indeed correct. So you can cross multiply, and if they're both 45, then you know they're both equal.
Oh, okay.
So do you see what Mickey's putting up on the board right now?
Yeah.
Okay, so when you cross multiply 5 by 9 and then 15 times 3, you come up with 45 both times.
Yeah. So really what that's doing, Ollie, is just confirming that my math is correct and I did follow the correct ratio and the correct factoring of how much of a large increase or a decrease that it was supposed to be. Is that clear to you?
Yes.
Okay,
All right.
sweet.
Nicely done. If you do need some more help, we are available until 5:30 this afternoon. And we do have another opportunity to head back out to Tejon Conservancy.
Hey, you know, no matter where you go in the real world, math is happening. And it's happening again with my friend Mitchell. Mitchell, we are by another very small tree. Sarcasm there. Pretty darn large tree here. And we want to do some measurements, some of the things that you do in your job. So first of all, one of the things that comes to mind when I think of plants, especially in our part of California, is water, right? We want to know how much water they have available and what they do with it, and you have a way to measure that.
Yeah, especially in the light of the last few years, right? We've experienced pretty substantial drought. So a lot of people notice that, hey, you know, the national forests, why are all the trees dead all of a sudden? So what I was hoping to show you today is a quantitative way of measuring how thirsty a plant is.
Right, yeah.
And we can do that right now.
And so what kind of tree is this, first of all?
This is a valley oak tree,
Okay.
Quercus lobata. It's a pretty dominant landscape feature in the San Joaquin. You get this all over Tejon Ranch. Of course, we're on the Mojave side of the ranch right now.
Right.
It's a deciduous oak species, and it's just my favorite species of oak.
Right, and similar to what we talked about last time, which was you can't just look at something and know how old the tree is. You can't look at this tree and know how much water or how much drought has affected it, because just because this branch doesn't have any leaves on it doesn't mean it's dry or dead, right?
Exactly.
So you're gonna take a sample here?
Yes, so this is a common method that plant physiologists specifically will use to measure how thirsty a plant is. And so they'll come in the field, and agronomists, farmers will use this same method as well. They'll come in the field and they'll just take a branch sample just like this. And ordinarily we would put this in a cooler so it doesn't transpire.
Right.
But we have the instrument with us right now. So we'll just go and put this right in the instrument and we'll talk about it there.
Yeah, let's go do it.
Sure.
Okay, Mitchell, so we have your sample. And again, we can't just look at it and know what we're looking at. So you have some equipment here that's gonna be able to do some give us some quantitative data, right?
Yes. This is called a Scholander pressure chamber.
Okay.
It's essentially a chamber where a gas tank is hooked up to this chamber right here. that if we take the top here and we put the plant sample from the oak we just collected and put it inside, there's a grommet that we can tighten, right?
Okay. So that's going to be hanging from the top of the lid.
It's hanging from the top, and the
Right.
top is exposed to the atmosphere, but the plant itself, the leaves and so forth, are going to go inside this chamber here. Okay, so I'm going to close it. This is very heavy. Okay, and the reason why we're using pressure is that one easy way to think about plants is that they're essentially straws. They take water from the soil and they push it up and out to the atmosphere through their leaves.
Yeah.
That is an energy-intensive process. Water is a heavy molecule, especially in the context of drought. Plants have to pull that much harder to get water out of the soil and push it toward their leaves.
Yeah.
And so that's why essentially we're using pressure, because if you put the plants under pressure and exude the water from the outside, you can get a measure how much pressure does it take. The more water stressed a plant is, the more pressure it takes to get the water out.
Okay, that makes
So
sense.
that's what we do.
So it's all lined up here. Now you're going to add some pressure.
Yep, so we just put the plant in the chamber like this, and this is measured in pressure units, megapascals.
Okay.
And so the pressure, it's hooked up to this nitrogen tank here, and now we're just going to turn the chamber on, so you can kind of hear the gas flowing in there, and if you look at the gauge, you can see that the pressure is climbing.
Yeah.
So it's measuring in megapascals.
700, 800.
It's climbing
900.
pretty quickly. Most plants, like your typical house plant, it would probably be dead around -2 or -3 megapascals.
Okay.
We're already well past the point, and you can see the xylem sap exuding out of the cut end
Yeah.
of the stem.
Yeah.
And so I was, let's say that was at -2.5 megapascals. And so this tree is well hydrated. But if we were to come back in the fall, it might be at -5, it might be at -6. And that's when the tree might start to experience the effects of drought.
Right.
We see some of these trees here, their canopy is pretty low, and so you can really kind of see the qualitative effects of drought. But this is a real hard and fast number that you can measure.
So this
drought
gives you
stress.
information in the here and now, and that coring sample you took earlier gives you long-term data, and you put
Yes.
those two things together, and you really can see how drought can affect a plant,
Yes.
both immediately and over the long term.
This is something that you can do repeatedly over the course of a year or even many years to
Right.
track an individual plant or even community's growth and see how it's doing over the long term.
Right, right. Oh, I love it. This is great. The numbers are here, even though we're in one of the most amazingly beautiful places I think that I've ever visited. The numbers are still here, and we can use those numbers to be able to figure out what's going on around us and figure out how to hopefully measure things going on in the future. We know there's more numbers back in the studio though, so we'll go back there now, and we will be back with a couple more interesting topics here at the Tejon Ranch.
Once again, thank you for that, Scott, right there. And thank you also to all of the folks at the Tejon Conservancy. We've had some great visits when we had the opportunity to go out and visit with those guys. 636-4357 is the phone number. Phone tutors are available 3:30 to 5:30, most Tuesdays and Wednesdays throughout the regular school year. The live program, in case you're tuning in and you're like, hey, usually you guys got done at 5. Well, we moved it from 4:30 to 5:30 because there are some schools that have taken later start times during the day, so we wanted to be able to accommodate you with a later start time for Do the Math. In studio, we have Jaxson, a 5th grade student from Williams Elementary, loves 5th grade so far, and you like best that you're just learning new things.
Yeah.
Do you have any idea, I know you're only in 5th grade, you're 10 years old, but have you put any thought into what you might want to do when you become older as far as an occupation or a career?
Yes, I would like to be a vet.
You'd like to be a vet?
Yes.
All right. I'm sure you like animals, right?
Yeah.
That's probably a big reason why you would like to do that.
Yeah.
So you want to get into medicine and specifically for animals.
Yes.
All right.
Now,
good.
do you want to focus on like what people would call like maybe a typical veterinarian, cats, dogs, hamster, things like that, or are you looking for more like horses, cows, goats, more of like large animal veterinary?
I think probably both.
Cool. All right.
Yeah,
I know a lot of people think veterinarian. They think dogs and cats.
Right,
but
those are the only ones,
Someone's got to go out there and take care of the horses and the cows and the llamas and the alpacas of the world. So it's always interesting to see if people want to engage with those larger animals.
Perhaps you can pick up a second career also.
Yeah. I don't know about that. But we can talk about the weight of the animal and how much leverage you need to pick the animal up. But that's about it.
All right, well, we're not even going to bother with that right now because we're going to put the young man back to work.
All right.
All right, Jackson, over to the board if you do, please. Head on over. I would like you to select any 2-digit number and write it on the board. That is awesome. Stop right there. 23. Why 23?
Oh my goodness.
I mean, it's just a number that I really thought of.
You just like the number, right? And I did not
It's
tell
not
you
too
anything about a number to put up there, did I?
No.
No. Well, there are a lot of people that know me, and they know that 23 is a big number for me because 23 is the number of my favorite New York Yankee of all time, Don Mattingly. Did you know that?
No.
It's true. Mickey knows it, right? Big Mac,
As
you
soon
know
as you
it.
wrote it, I was wondering if he was going to pick
I
up
had
on it.
no input on that at all, but it's just funny that you wrote 23. So either next to it or underneath it, select another 2-digit number.
We'll put it underneath.
Okay.
Ah, yes, 96. It's just 96. That's
Your birth year.
Oh, there we go.
You didn't even realize that?
No, I'm not looking for that. That's just a number.
Okay, so Jackson, any reason for 96?
Just because it's really high. It's more higher, so it'd be more of a challenge and not just an easy
Yeah.
12 by 12.
Well, how do you know you're going to multiply those numbers? I didn't say what you were going to do yet. Maybe I'll have you divide them, throw something into you, but no, we're going to multiply them. So multiply those two numbers and explain to Mickey how you're doing it as you go through the process.
So I'm going to use the method regrouping. 3 times 6 is 18. I need to put down the 8 and carry the 1 over the 2. And then 6 times 2 is 12, but I need to add the 1, which would be 13. Next, I need to put 0 for the 6 because I already multiplied that number. Then I need to do 9 times 3, which would be 27. Now I do cross that out and put a 2. Then 9 times 2 is 18. Add 2 is 20. And then from there, I would need to add these together. And that'd be, I need to carry the 1 over since I got into the tens place over there. Then 2, because 1 plus 1.
Very good.
And then I need to bring down the 2 since I have nothing to add it with.
So our product, or the answer to our multiplication problem, is 2,208.
Yes.
Is there another way to multiply those that you've learned instead of just doing it that method?
You might call it the standard algorithm. Have you ever heard of the box method or any of those
Yes.
other ones? Okay.
Would
Go
you like
for
me
it.
to do
Yeah, I'd love to see that. So then for box method, we put each number and its individual value, correct?
Yes.
Okay.
And then okay, now I would need to do 90 times 20, which I can just do 9 times 2, which would be 18. Add the zeros.
Nice.
The next I would need to do 90 times 3. 9 times 3 is 27. Then add 1 0. Next, I need to do 6 times 20, which 6 times 2 is 12. Add 1 0. And 6 times 3 would be 18.
Very good.
And then from there, I need to take all my numbers.
And we have 270, 120, and 18.
From there, I need to add them all up. 0, 0, 0, 0, 8. 7 plus 2 is 9, plus 1 more would be 10. I need to carry over the 0. Then 1 plus 8 is 9. Add 2 would be 11. Then add a 1 would be 13. You put down the 3, carry over the
11 plus
0.
1 again, what is it?
Wait, 11 plus, oh, 12.
There we go, all right.
Wait, I can leave that.
Yep, you can include that, very good.
And then 1 plus 1 is 2.
Nice job. Answers match?
Yes.
Nice work. Now there's one thing I wanted to touch on. So you say carry, right?
Yes.
Do you know why we carry? Or what it means in mathematical terms?
Regroup.
Regroup. Yes, I want to challenge you to say the word regroup, because really what we're doing, if I have 3 tens, because this is the tens place, right?
Yes.
And 7 tens, am I allowed to have 10 tens in here in the tens place?
No.
No, so what we're doing is we're taking those tens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm taking them and I'm turning that. You ever see the 100 block in school?
Yes.
When you were younger and it had all the cubes on it and all that stuff, and you're like, oh, I know this represents 100.
Yeah.
Well, these 10 tens, or these 3 tens and these 7 tens combined, well, if I combine them, are there any tens left?
No.
No. I take them and I turn them into a 100 value, which is why we have 0 tens left, and we bring over 1 in the hundreds, because I turn them into 1 100 value. Does that make sense to you?
Yes.
Perfect. So that's really what regrouping is. A lot of teachers and students will say carry. The mathematical reasoning is because we're making enough, because in math we're based on the number 10. Once we have 10 of something, we can make a new value for the larger place value. Nice job, man.
And I like that you did that with the word carry, because a lot of instructors do that, and then kids get used to saying, well, I'm going to carry this over, but you're actually regrouping.
Right.
And the explanation that you guys had right there was perfect, spot on for that, so thank you for that.
I'm glad you knew it also. Nice job.
And that also would have been beautiful for our language of mathematics last year, carry,
There we go.
right? Because when some kids go, oh, I'm going to carry something, they pick it up and
I ask my
it
students, they
someplace,
say
right?
carry the 1. I go, okay, pick it up. And they're like, well, I can't do that. I go, you
Right.
can't use carry then. We
Right,
must
so
regroup it.
Another reason, that is another way that they can probably remember that. Carry the 1. Well, where are you going to bring it to? Right?
Bring it to the
Pick it up and carry it, right? All right. So what I'd like you to do is, you guys can go ahead and clear that board. So Jaxson, we're going to use your same 2 numbers, 23 and 96.
Okay.
And earlier, you had said that you're comfortable multiplying 2 digits by 2 digits, which you are.
Yes.
But I also threw something out and said, have you ever done it with decimals yet? And you said no.
Oh.
So that's what we're going to do now to get you better prepared for later on in 5th grade, because you will do this later on this year. Okay? So Mickey's going to help you with some decimals in those same 2 numbers.
Ready?
Yes.
Nervous?
Yeah.
It'll be okay,
Okay.
I promise. All right, so I'm going to put a decimal here
Okay.
and a decimal right here.
Okay.
Let me ask you this. Does 6 times 3 still make 18?
6 times 3.
Is it still 18?
Wait, yes.
Yeah, okay. What I want you to do is just work the problem out. Just like you would any other way. Just
Okay.
ask yourself, can I do multiplication, and go from there, okay?
Okay, so I just multiply it just regular?
Yep.
Okay. So just pretend like
No,
the
you can use mine. Yeah. Use mine.
Wait,
do it
oh,
here.
okay.
Yeah, do it
Yeah.
here. Yeah, you're fine.
Okay.
Just go ahead and work it out.
6 times 3.
Regroup the 1. Very good.
12.
I'll scoot down a little bit for you. Nice work. Keep it going. Almost there. Hey, look at that. Is that the same as our last one?
Yes.
But there's 2 decimals. And a lot of students go, oh my gosh, there's decimals. What do I do? And I go, it's a dot. Is a dot going to change that 6 times 3 is 18 or 6 times 2 is 12? No, it's just a dot, right? What it does change is the value of those. So our answer is not really 2,208. What changes is all of a sudden I have 1 factor of 10, 2. I have 3 factors of 10 because there are 3 places behind the decimals in total. Does that make sense?
Yes.
So I have 1 factor of 10 from up here. How many factors of 10 are behind the decimal here?
2.
2. Well, if I have 1 up here and 2 here, how many are there in total?
3.
3, which means really this answer should be 3 factors of 10 smaller.
3 factors of 10 smaller.
Right? So here's the way we think of that. Every number, if no one told you this by now, I'm going to let you in on a secret. Every number in the world, that's a real number, a positive integer for my math teachers out there, has a decimal. Even the number 7 has a decimal. It's just hiding. It's
It would
really
be a 0.
7.0. Is it still 7?
Yeah.
Yeah. It has a decimal in hiding, which means 2,208 really has a decimal here. But like you told me, there are 3 factors or powers of 10 that are smaller or less than a whole number. So because I have that 3 times smaller, or 3 powers of 10 smaller, I need to make this 3 powers of 10 less in value. So to do that, I move it back. 1 power of 10, 2 powers of 10, 3 powers of 10. Because really, if I have 2.3, 2 and 3/10 times 96 hundredths, it's not even a whole number 1. Well, Jackson, if I do, let's say, 2.3, 2 and 3/10 times 1, does anything happen?
No.
What's my answer going to be?
2.3.
2.3, 2 and 3/10. So, is 96 hundredths less than 1? If it's 0.96, is that less than 1.0?
Yes.
It is. So my answer should be less than what I get by multiplying by 1. Is 2.2 smaller than 2.3?
Yes.
Yes, it is. So our answer checks out. So really, a lot of students say, oh my gosh, decimals scare me. It's not the decimals that are scaring them, it's what to do with them at the end. So when you did the math, did the decimals actually change how we multiply or add them together?
No.
No, it simply changes our product and how we value each number. They all have to become 3 powers less in value. So instead of this 2 being worth 200, it's now worth 2/10. Does that follow?
Yes.
Awesome. All right.
So I'm going to give you guys 1 minute and just go over the place values after the decimal.
What they're called?
Exactly.
Okay. So Jackson, let's just start in front of the decimal just to get our bearings here. What place value is the one directly in front of the decimal?
In the ones place?
The ones place, absolutely correct. After the decimal, we start to get in fractions or parts of a number. What's this first place value called?
The hundredths?
Close, think
Wait.
smaller.
Tenths.
Tenths, very good. Now, even though there's a 0 here, we still have a place value name, don't we? What do we call that one?
The hundredths?
The hundredths, yep. And after that?
The thousandths.
The thousandths, yeah. You'll notice it follows that same pattern if we were to go to the left of the decimal into whole numbers. So after the ones, we have the tens. Then we go to the hundredths. Then we go to the thousands.
There you go, nicely done. So I just wanted you guys to do a quick explanation
You just don't have the ones on
of
the
the
other
place
side.
values right there. All right, we do have phone tutors available until 5:30. We have one last opportunity to go visit the folks at the Tejon Conservancy.
Hey, math continues to happen in the real world, and even though we don't have a gigantic tree behind me, we do have some numbers happening here, and we have some more nature things happening here. We're on the Tejon Ranch still, and I brought another one of my friends, Steve. Thanks for joining me today. Can you tell me a little bit about what you do and why the heck we are out here? Because there's not many trees where we are right now as opposed to where we were before.
One of my primary functions is to track a small herd of pronghorn that we have on the ranch.
Right.
We have the largest group sizes we've seen are up to like 34 animals, which would be a mix of bucks and does and fawns or yearlings.
Right. And for those of us who don't know, tell me a little bit about pronghorn. They're pretty unique, right?
They're totally unique to North America. That it is not. Sometimes people refer to it as an antelope,
Yeah.
and it's not really an
It's
antelope.
not, okay.
But every once in a while, I'll slip and call them an antelope as well.
Right.
We are in the Antelope Valley.
Yeah, there you go.
And it was named after primarily the large numbers of pronghorn that were here before the turn of the 20th century. So back in the 1880s, 1890s, there seemed to be an awful lot of the animals, and then they disappeared. The ranch was able to reintroduce the pronghorn to the ranch, and they did that in 1985, 86 era. And we've inherited, with the Conservancy, we've inherited the residual group of pronghorn that were originally planted here. So a lot of my work and the team people I work with is we're trying to improve and enhance the environment, enhance their ability to survive. And there's some unique characteristics about these animals and one of the reasons why we're here is that they're a plains animal. They like wide open spaces.
Right, so we wouldn't see them in those trees where we were before, but this is exactly where we might find them.
Well, they might get in the shade of one of these trees during the heat, the really heated areas, but generally no. They're going to want to have this wide open expanse because they have a 300-degree view with their eyes,
right,
and they can see movement. I've read reports that say that they can detect motion up to 3 miles, which is pretty remarkable.
Amazing abilities, yeah. So they really want to be in an open space so they can see if predators are around and
Exactly.
know that they're coming from a long way away.
That's right.
So what kind of research do you do to keep track of numbers or to make sure that the herds are healthy or whatever? You know, what are you looking for?
Well, we have a route that we try to keep. And the route is largely dictated by the fact that we stay to roads that are already existing.
Okay.
All right, so we follow the existing roads, and we're looking for any group, any single animals, any group of them, and then we compile that data.
Right.
When we do find them, we locate them geolocate them on our iPads.
Okay.
Take that data and then manually record it on a survey data sheet where we record the information of the dates and the times and the location. And the reason we do the location is we're monitoring the movement of the animals.
Yeah.
So we have to know where they're going to be able to spot them, and we have to know where they're going to deal with issues in the environment that may be impairing their ability to go through there.
And that sounds like a pretty tough thing because I heard they're pretty fast. Hard to track these guys because they are pretty quick.
Well, they're the fastest land mammal, and they're capable of bursts of speed up to 60 miles an hour has been reported, but they can sustain 40, 45 mile an hour speeds for a long period of time.
Wow.
If you look at their nostrils, they're very large. They have a very large windpipe, and butts and air pump. They're sucking in volumes of air to sustain that motion. But
it sounds like they're really adapted to this area, and it makes sense that we talk about antelopes as far as a reference point for most people because they don't know what a pronghorn looks like. But it sounds like this is really the area where they thrived at one time, and now they're going to start thriving again because of efforts such as yours. We want to really thank you for being, well, I know I'm really, I learned a lot today because there's a lot of things I didn't know about those things. Look at our famous do the math tile. I want to make sure we give you that as a parting gift. Really appreciate your time today, being able to help us out and to know a little bit more about the pronghorn. And oh man, unbelievable things here at Tejon Ranch. And we'll wrap it up and send it back to the studio.
And once again, a big thanks to all of the folks at the Tejon Conservancy. Thank you to Scott also. And just amazing, everywhere you are able to do math, right? Did you ever think that you could go out to Tejon and check out the pronghorn and be able to apply math to it?
No.
It'd be a job one day. You go out there and you're looking at animals, documenting where they are. I mean, it's a lot better than a lot of jobs like I've heard some people have to deal with. So math
so
does
Jaxson,
help.
did you learn a little something today?
Yes.
Good. Did you have fun today?
Yeah.
That's the more important thing right there. You're our newest ambassador. Do you know that? No. That means you're going to tell everybody else about Do the Math. So when you wear your shirt, you are the official ambassador of Do the Math. You can do that?
Yeah.
All right. Excellent. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.